Greetings and welcome, friends. I'm taking a look at a little warm-up question talking about inequalities later today. And it says, which of the following is true, are true, is true? Because only one of them is true. So first of all, is 0.9 with this little bar? The little bar, by the way, it means repeating. So that's point with infinitely many nines after it. All right. So I'm not implying rounding here. I'm saying, is that greater than 1? And most people said no to that. That didn't make much sense. Is 0.9 repeating equal to 1? All right. Once again, I'm implying it's not rounded. I'm saying equal. All right. Or is 0.9 repeating less than 1? And I had pretty much all my students said C here, but let's investigate this a little bit. Let's consider C for a minute. If 0.9 repeating is not equal to 1, if it's less than 1, then there should be some number that I could add to it that would make it equal 1, right?
Yeah.
Would you guys agree? What do you think I could add to this?
0.1.
With a little y over it.
Well, let's think about this. 0.9 plus 0.1, that would equal 1. All right, do you guys agree?
Yes.
All right, 0.99, what would I add to that one?
0.001.
0.01, that would equal 1. Or 0.999 plus, this one would be 0.001, that would equal 1. So if I skip this process a little bit, and I had 0.9 repeating, it looks like what appears to be the pattern for the number that I'd have to add to this.
0.1 repeating.
0.01 both repeating? This?
Yes.
That would be 0.011111. It looks like the zeros are getting more and more each time, right?
So you know, just the zero.
And I agree with you. That's what appears to be the case here. However, the issue is that this is not a number. That doesn't exist. Because I can't have infinitely many zeros and then be like, all right, timeout, stop. I'm going to put a 1 at the end of those. Because then the moment I put a 1 at the end of it, it's no longer infinitely many of them. I stopped the infinite list. Right? And then I can't be like, oh, sorry, I didn't mean to stop you so early. Let's go back and have more zeros. Give me some more zeros. And then it's like giving me infinitely many zeros. And I'm like, all right, stop. I'm going to put a 1 at the end of it. Right? That doesn't work because I've stopped it. So this is not a number. Huh. So this seems to be revealing the fact that there's no such number I could add to 0.9 repeating that would give me something equal to 1.
But C is still correct.
C is still correct, you're saying. Really?
0.9 is less than 1.
Okay. All right. Let's see. Let's consider this little thought process. What is 1/3 equal to as a decimal?
0.666.
No.
3.
That would be 2/3. So 0.3 repeating is 2/3, right? What if I double that?
Then you have
2/3.
I'd get 2/3 is equal to,
0.6 repeating.
right? I think I agree. What if I take 1/3, which is equal to 0.3 repeating, and I triple it?
Have 3/3 or 1.
All right, so that's 3/3 is equal to, what's this equal to?
It's supposed to be equal to 9 repeating.
And 3/3, Moro just said, is equal to 1. Huh.
Don't reach your repeating sign.
That appears like that's true based off of the math we just did. Here's another way to look at it. This technique, by the way, I'm a fan of the video game company Blizzard from Anaheim, California. They make StarCraft and Warcraft and things like that. Hearthstone, a pretty good card game there. And on April Fools, they often end up posting some sort of spoof jokes on their website, right? And they ended up, one April Fools, they decided that they were going to post the fact that, 0.9 repeating equals 1. And this was the proof they ended up justifying it with. They were claiming as though apparently their forums had been filled with discussions about what 0.9 repeating was equal to, and and they finally were going to settle the issue, which I'm guessing their forums weren't actually all about that. But nonetheless, this is the proof that they posted, and this is my favorite proof. So let's see, if x is equal to 0.9 repeating, all right, I'm just saying, like, I just defined the value of x. What do you think I would get if I multiply both sides by 10? All right, and I'm allowed to do that. So I'd get 10x on the left equals, and multiplying by 10, what does that do to a decimal?
Makes it a whole number?
Well, it shifts the decimal, right?
Makes it smaller.
Okay.
Well, what is 10 times 3.127 equal to? Does anyone know? All it does is
30 point.
yeah, shifts the decimal. So it's 31.27. All right. So if I shift the decimal here, this is going to be 9 point. And now how many 9s are left? I just took one of the infinitely many 9s.
That's not word. Infinitely many nines.
So infinity minus 1 9s are left over,
No.
which are still infinitely many.
Yes.
Yeah, that's kind of weird, isn't it?
Except for that doesn't work because when you multiply times 0.9, it gets less.
What do you mean? Well, this. Oh, well, if it was just plain 0.9, I agree that it would be less. But I'm claiming that this might not end up being less. And if your theory that 0.9 is less than 1, then you would also have argued that 9.9 repeating is less than 10. So it did get smaller, so to speak, according to your perspective. But nonetheless, I shift the decimal by multiplying by 10. I take one of the infinitely many 9s, put it in front of the decimal, and I still have infinitely many minus 1 9s left over, which is still infinity. Okay, so this is kind of weird. What if I now subtract an x from both sides? All right. What's 10x minus 1x?
10.
No. Oh, that's a super common mistake right there. Remember, this is like 10 apple pies minus 1 apple pie. 9 apple pies, right? Equals, and this is now 9.9 repeating minus, and what was x equal to again? What was my original?
0.9 repeating.
I claimed that was equal to 0.9 repeating. So instead of having minus x here, I'm going to write this as 0.9 repeating, because those are equivalent based off of my previous claim, right? That 0.9 repeating, I could just plug right in here for x. And what do you think 9.9 repeating minus the 0.9 repeating is equal to?
9.
Right? Yeah, I'm subtracting off the infinitely many 9s after the decimal. And how would I solve this for x? You guys know how to do
Divide
it?
by 9.
Oh, I like it. And I would get x equals 1. Well, now that's either I made a mistake, or we've reached some sort of paradox, or these things are really equal. Because earlier I said x was 0.9 repeating, and now I'm saying x is equal to 1. What? So it turns out the correct answer to this, and by the way, this is called a trichotomy, the fact that one number will be bigger than another number, equal to that number, or less than that number. There's only 3 possible outcomes there. But it turns out that 0.9 repeating is equal to 1. Not rounded, but equal. Exactly equal. And I know that's kind of weird. And people are like, well, why would they write it that way? And I just want you to think about it this way. 0.9 repeating is just another way of writing 1. Right? Just like earlier we said 3/3 is equal to 1. Those are both equal to 1. It's just another way of writing it. All right? So just think about it kind of like that. 0.9 repeating, turns out it's equal to 1. Mind blown. Bye-bye, internet friends.